All right, 16b, here's another video about disk and washer method. So here we're trying to find the volume obtained by revolving the region in quadrant 1, bounded by y equals x squared, y equals 6 minus x, and x equals 0. So that's y equals x squared, y equals 6 minus x, and x equals 0. We didn't specify quadrant 1 because if we said just bounded by those things, then it'd be we wouldn't be sure if it was this region here or whatever was over here. We do need to find where these intersect. Now here's the thing. Oh no, that's fine. Yeah, sorry, I thought, yeah. You could set them equal to each other and solve, right? It's not that bad. If you set x squared equal to 6 minus x. But you can also just kind of guess. Right? If x equals 1, this is 1, this is 5. If x equals 2, this is 4, and this is 4. Oh, it's 2. But you could also be like x squared equals 6 minus x. So this one here is x equals 2 and y equals 4. Now here's the thing about this one particularly. Going around the y-axis here, we see that we have a different kind of shape below and above this. So we actually have to set up two integrals. So for the volume of this bottom part that's kind of like this bowl thing, right? We have to do the volume of this disk added up from 0 to 4. So for the bottom part, the volume of the disk, well, let's see. The volume of the disk is pi times the radius squared times dy, because dy is the thickness. The radius is just the length of this function, but again, it's in terms of y, so it's not y equals x squared, it's x equal to the square of y. And so the volume of the bottom part in total is going to be the interval from 0 to 4, because that's how far these strips go, where the left-hand side is this and the right-hand side is this, of pi times square root of y squared dy. Which I guess we should just calculate, right? So that's going to be pi times y dy. We're going to integrate. We're going to get pi y squared over 2 from 0 to 4. When you plug in 4, you're going to get pi times 16 over 2, which is 8, so you're going to get 8 pi. And then, right, because 0 gives you 0. That's not all, though, right? Because I'm going to do the top part. So the top part, it's going to be, well, it's going to be the integral from 4 to 6, right? Because this is intercept is 0 to 6. Pi times the radius squared dy. And here the radius isn't x equals the square root of y. It's the linear function y equals 6 minus x, except if we solve for x, it's x equal to 6 minus y. So it's that. So that's going to be, now I have to multiply this out. That's going to be 36 minus 12y minus plus y squared. Just brought the pound in front. Which is going to equal pi times, let's see, 36y minus 12y squared over 2 is 6y squared. Plus y cubed over 3. From 4 to 6. Numbers are not pretty. 6 times 36 is 216. 6 times 36 is 216. And 6 cubed over 3 is 216 over 3. Minus, plug in 4. 36 times 4 is 144. Plus, right, because the minus, well, let's just do minus like that. 6 times 16 is 96. And then 4 cubed is 64 over 3. So we end up with, let's see, pi times 216 minus 64 all over 3. And then we have negative 144 plus 96. That's going to be a negative 48. Right? Yeah, negative 48. So sorry, I know I'm running out of room here. 216 minus 64 is something. It's 152. Right? 216 minus 64. Yeah, 152. 152 divided by 3 is not nice. So we have pi times 152. And 148 times 3 over 3 is 144 over 3. So we end up with 8 pi over 3. Right? Yep. So our total answer is this plus that. So our total is 8 pi plus 8 pi over 3, which is 24 plus 8 is 32 pi over 3. Okay. Also, just to point out, you totally could have found the volume of this top shape revolved around. Not that you should, but that's actually a cone, and so the volume is 1/3 pi r squared h, where the radius is 2 and the height is also 2. So it's 1/3 pi times 2 squared times 2, which is 1/3 pi times 8, which is 8 pi over 3. So it actually is that. Other side, what if we go around the x-axis? So still the same function. This is still y equals 6 minus x. It's still y equals x squared. Still x equals 0. They still intersect at 2, 4. So the plus side about this one is we don't have two different intervals we have to do, right? The top is always just 6 minus x. The bottom is always just y squared, x squared. Not true here, right? Here the right-hand side changed, right? From 0 to 4, the right-hand side was this. From 4 to 6, the right-hand side was this. So here, it's nice in that we can just have the same thing, but we have to use the washer method. So the volume of this disk is pi times big radius squared minus little radius squared times dx. Again, my strip is perpendicular to my axis of rotation. Just like on the previous one, my strips were perpendicular to the axis of rotation. And then, so my outer radius, right? So this is my outer radius. That's just the function that's further away from the x-axis. That's 6 minus x. Capital R is 6 minus x. And my inner radius is just the closer function, which is the x squared function. Right? That's my inner radius there. Or if you like, right, that's my inner radius there. And that's just y equals x squared. So the volume of my disk is pi times the quantity 6 minus x squared minus x squared squared. And we can simplify that. In fact, we should. That's pi times 12. Sorry, not 12. 6 squared is 36. 36 minus 12x plus x squared minus x to the 4th. So then the volume total, we're just going to add up all of the disks. We're going to integrate from 0 to 2. So we're going from x equals 0 all the way over here to x equals 2. Bring out the pi, and we've got 36 minus 12x plus x squared minus x to the 4th. It's not going to be pretty. So we end up with, let's see, pi times all of 36x minus 12x squared over 2 is 6x squared plus x cubed over 3 minus x to the 5th over 5. Ugh. From 0 to 2. The good news is when we plug in 0, we get 0. So we just plug in 2, and we get pi times 36 times 2 is 72. 6 times 4 is 72. 6 times 2 squared is 6 times 4, which is 24. 8 over 3, I get 32 over 5. 72 minus 24 is a number that is 48. And you get a common denominator here. Let's see, 5 over 5 is going to give me 40 over 15. And 3 over 3 is going to give me 96 over 15. So I'm going to get, let's see, pi times negative 54 over 15. 56 over 15, and sometimes. And 48 times 15 over 15 is blah. So here's how I multiply by 15. I multiply by 10, and then half that, and add it again. So 48 times 10 is 480. Half of that is 240. 480 plus 240 is 720. That's 48 times 15. So 720 minus 56 is equal to something. It's equal to 664. Actually, yeah, 56. Yeah. So there's our answer for the volume of this bizarre shape. Hopefully that helps clarify some of these problems for you guys.